The story of computer hardware evolution since the 1970s is one of extraordinary ingenuity, relentless innovation, and profound societal transformation. The machines that once filled entire rooms and performed only the simplest calculations have, over the decades, become the foundation of modern life, compact, powerful, and deeply embedded in everything from communication to commerce, entertainment to education. To appreciate the magnitude of change, it is essential to trace this journey, decade by decade, exploring the pivotal technologies, landmark devices, and visionary minds that shaped the digital world as we know it. In the 1970s, computers were largely the domain of governments, universities, and large corporations. Mainframes and mini-computers, produced by companies like IBM, DAC, and Honeywell, dominated the landscape. These machines were massive, requiring dedicated rooms with specialized cooling systems, and operated primarily through punch cards and magnetic tape. Their processing power, by today's standards, was minuscule, but they represented the cutting edge of technology at the time. The IBM System 370, introduced in 1970, epitomized the era's mainframes, offering improved performance and reliability for business data processing. Parallel to these giants, the seeds of personal computing were being sown. The introduction of the microprocessor in 1971, specifically Intel's 4004, marked a revolutionary shift. For the first time, the Central Processing Unit, CPU, could be integrated onto a single silicon chip, drastically reducing size and cost. This innovation made it conceivable for computers to move out of research labs and into homes and small businesses. By mid-decade, hobbyist kits like the Altair 8800, which used Intel's 8080 microprocessor, ignited the imaginations of a generation. The Altair's success spurred the creation of user groups and inspired young entrepreneurs, including Bill Gates and Paul Allen, who developed a version of BASIC for the machine, an early milestone for what would become Microsoft. The late 1970s witnessed the birth of the personal computer as a consumer product. Apple's Apple I and II, Commodore's PETI, and Tandy's TRS-80 brought computing to the masses. These machines featured integrated keyboards, video displays, and storage options such as cassette tapes and floppy disks. While still primitive, they offered unprecedented accessibility and flexibility, enabling individuals to program, play games, and manage simple tasks. The Apple II, in particular, set new standards for expandability and user-friendly design, foreshadowing the trajectory of personal computing for decades to come. The 1980s heralded an explosion of innovation as the personal computer market matured and diversified. IBM's entry into the market with the IBM PC in 1981 established a de facto standard for hardware architecture. The open nature of the IBM PC allowed other manufacturers to produce clones, fostering intense competition and rapid advancement. The x86 family of processors, beginning with Intel's 8088, became the backbone of the industry, their instruction set architecture persisting to this day. Meanwhile, graphical user interfaces, GUIs, began to emerge, notably with the Xerox Alto, and later with Apple's Lisa and Macintosh. The Macintosh, launched in 1984, popularized the mouse-driven interface and high-resolution graphics, making computers more approachable for non-technical users. Storage technology also advanced rapidly during this period. Floppy disks became ubiquitous, providing a convenient medium for software distribution and data transfer. Hard disk drives, once prohibitively expensive, gradually became affordable for desktop computers, offering vastly greater capacity and faster access times. Printers and monitors improved in tandem, with dot matrix and later laser printers delivering higher quality output, and color displays enhancing the visual experience. Networking began to take hold in the 1980s, laying the groundwork for the interconnected world to come. Ethernet, invented in the 1970s, gained traction as a standard for local area networks, LANs, enabling multiple computers to share resources and communicate. Modems connected home computers to bulletin board systems, BBSs, and early online services, foreshadowing the Internet's eventual pervasiveness. The 1990s were defined by exponential increases in computing power, falling prices, and the dawn of the Internet age. Moore's Law, the observation that the number of transistors on a chip doubles approximately every 2 years, continued to hold true, driving relentless improvements in speed and efficiency. Intel's Pentium processors, introduced in 1993, set new benchmarks for performance, while rival companies like AMD pushed the envelope with competitive offerings. The proliferation of Microsoft Windows, especially with the release of Windows 95, standardized the GUI-based computing experience for millions. This era saw a convergence of hardware and software advances. CD-ROMs replaced floppy disks as the primary medium for software and multimedia content, offering vastly greater storage and richer experiences. Graphics cards evolved rapidly, with dedicated GPUs from companies like NVIDIA and ATI, enabling sophisticated 3D rendering for games and professional applications. Laptops, once bulky and underpowered compared to desktops, became increasingly practical thanks to advances in battery technology, display miniaturization, and low-power processors. The IBM ThinkPad series, Apple's PowerBook line, and Compaq's Armada demonstrated that portable computing could be both powerful and stylish. The rise of wireless networking, Wi-Fi, in the late 1990s untethered laptops from cables, ushering in new possibilities for mobility and collaboration. Perhaps the most transformative development of the 1990s was the mainstream adoption of the Internet. Dial-up modems gave way to faster broadband connections, and network interface cards became standard equipment. The World Wide Web, invented by Tim Berners-Lee, turned the Internet into a user-friendly platform for information sharing, commerce, and communication. Hardware adapted accordingly, with servers, routers, and switches becoming essential infrastructure for the burgeoning digital economy. The turn of the millennium brought further acceleration. The early 2000s saw the emergence of multi-core processors, allowing computers to perform multiple tasks simultaneously with greater efficiency. Intel's Core series and AMD's Athlon and Opteron chips exemplified this trend, pushing desktop and server performance to new heights. Memory capacities soared, with gigabytes of RAM becoming commonplace, and hard drive sizes ballooned into the hundreds of gigabytes and then terabytes. Graphics hardware underwent a revolution as well. GPUs, initially designed for accelerating 3D graphics in games, evolved into massively parallel processors capable of general-purpose computing. NVIDIA's CUDA and AMD's Stream Technologies enabled scientists, engineers, and researchers to harness GPU power for complex simulations, machine learning, and data analysis. Mobile computing experienced a renaissance with the advent of smartphones and tablets. Apple's iPhone, introduced in 2007, redefined what a handheld device could be, integrating powerful hardware, intuitive touch interfaces, and always-on connectivity. ARM-based processors, known for their energy efficiency, became the standard for mobile devices, challenging the dominance of x86 in the broader computing landscape. The iPad and Android tablets further blurred the lines between traditional computers and mobile devices, expanding the reach of computing into every aspect of daily life. Storage technology continued to evolve, with solid-state drives, SSDs, replacing mechanical hard drives in high-end systems. SSDs, based on flash memory, offered dramatic improvements in speed, durability, and energy efficiency, transforming everything from boot times to file transfers. Cloud storage and computing emerged as major trends, allowing users to access data and applications from anywhere, on any device. The 2010s and beyond have been characterized by miniaturization, integration, and the rise of ubiquitous computing. Desktop towers gave way to ultra-thin laptops, convertibles, and even stick PCs that fit in a pocket. Single-board computers like the Raspberry Pi democratized hardware tinkering and education, putting affordable, programmable computers in the hands of millions. Wearable technology, such as smartwatches and fitness trackers, brought computing power to our wrists, while voice assistants and smart speakers integrated artificial intelligence into everyday environments. The Internet of Things, IoT, connected everything from thermostats to refrigerators, creating a vast network of intelligent devices that sense, communicate, and act autonomously. On the enterprise side, data centers evolved into hyperscale operations, housing tens of thousands of servers managed by sophisticated automation and virtualization technologies. Graphics processors became indispensable for artificial intelligence, powering breakthroughs in deep learning, natural language processing, and computer vision. Companies like Google, Amazon, and Microsoft built global cloud infrastructures, offering computing resources on demand to businesses and individuals alike. Meanwhile, hardware security became a paramount concern, as the proliferation of connected devices exposed new vulnerabilities. Trusted Platform Modules, TPMs, biometric authentication, and hardware-based encryption became standard features, reflecting the growing importance of safeguarding data and privacy. Looking to the present and near future, the boundaries of computing are being pushed ever further. Quantum computing, though still in its infancy, promises to tackle problems intractable for classical computers. Neuromorphic chips, inspired by the architecture of the human brain, aim to deliver unprecedented efficiency for AI workloads. Edge computing brings processing power closer to where data is generated, reducing latency and enabling real-time decision-making in applications like autonomous vehicles and industrial automation. The evolution of computer hardware from the 1970s to today is not merely a technical chronicle. It is a narrative of empowerment and transformation. Each advance has unlocked new possibilities, reshaped industries, and altered the fabric of society. The journey from room-sized mainframes to pocket-sized supercomputers reflects humanity's unceasing quest to augment its capabilities, connect with others, and explore the frontiers of knowledge. As we reflect on this remarkable progression, it becomes clear that the story is far from over. The hardware of tomorrow will build upon the foundations laid over the past 5 decades, continuing to shrink in size, grow in power, and integrate more seamlessly into our lives. The next chapter, whatever form it takes, will be written by the innovators and dreamers who dare to imagine the impossible and then make it real.